Now we are going to see about a convolution problem. The problem given to us is a signal x of t of a figure A, that is x of t, this is the signal they are talking about, is applied to LTI system. LTI system means linear time invariant system of impulse response. We are going here for impulse response to that h of t shown on figure B, that is we are giving the input to this system for impulse response, which we are going to take about in as output. The value of DC component present in the output. The results they are looking for that is they are looking for DC component. They are not neglecting everything like in imaginary part and exponential part. They need just a DC component. From this given problem we can say that x of t, that is the input signal, which is equivalent to minus 2 RT, that is this minus 2 taken from this slope. This signal is ramp signal, this is increasing ramp signal, this is after that 0th point we will, that is x equal to 0th value, we can say that in second coordinate we have increasing ramp signal, in first coordinate we have the decreasing ramp signal. So these are the thing we have to input that in equation, that is x of t equal to minus 2 RT. In ramp signal we can manipulate or we can substitute as slope of the ramp as into RT. RT can also written as in using the step signal, we will see that later. And x of t equal to minus 2, that is this slope level, minus 2 RT, that is the limit of the range of the minus 2 RT is minus 1 to 0. The next part of the signal is 2R2, that is the first coordinate ramp signal, that is 2RT, 2R of t, which is gives the range of 0 to 1, 0 otherwise, because there is no signal given to us in the rest of the things. So next one is we are going to put values for this signal, that is the impulse signal, which is, this is not impulse signal, this h of t equal to u of t, that is this thing when the minus 1 in between the minus 1 to 1, which is also equal zeros always, otherwise it's zeros. To replace R of t, that is we don't know what is R of t, so replace that we substituting R of t equal to, that is we have to calculate everything in step signal, that because we have the elements in step signal also everywhere here step signal. If we change this to step signal, that will be easy to manipulate the output values. So R of t equal to t u of t, that is ramp signal will be multiplied with the time into that step signal, that is step signal into multiplied with the time, which gives the ramp signal. So we are going to apply this here, so we will have minus 2 t, that is t u of t 2 r u of t. So we are going to draw what are the combination we have through this. We are just draw that input signal, we just draw the input signal because we are changing the input signal. When according to the problem we can change the x of t or h of t, so we are here changing the h of t, that because the origin having that x equal to 0, that is first coordinate and second coordinate, the element of x of t is available, so we are changing the h of t only. So here h of, we have changed to x of tau. Here that origin, the first coordinate, second coordinate, increasing and decreasing ramp signals are available. So now we have to change to here, change the h of t. We are having h t minus tau, that is drawn here. The thing is that we have put that the t equal to 3 here, so that's why we got the t value into 2. So we getting a 1 value, 1 as the least value, 3 as the maximum value. So we will get the, we are not getting the any overlapping condition here, so we will not apply this range, that is this limit to that in the convolution formula. So next thing is we put the -2 value for t. So again it's combined as -1 as the minimum value, -3 as the maximum value. So we will not get that, sorry for that, -3 is the minimum value, -1 as the maximum value, so that we will not get that value of internal overlapping. Then only we can find that what are the response for the x of t in the impulse response. So when we applied value that t equal to -1, we will get the waveform, that is we get the signal as like this. The orange shaded position or the overlapped version of that two intercepting the signals. So that is the these are the things we are looking for. In other hand, we have, when we put the value for +1, we'll get the overlapping here also. So we have to find the exact value of here to there. This value we should find that combining these two, like here, like this. We have to find the value of this value. We have to find the region covered through this shaded orange position. We should confirm that is the value of what we are looking for, that the signal. So next we go to a convolution. We already find that what are the limits, what are the range we are looking for, that y of t equal to integration of -infinity to +infinity to x of tau h of t minus tau d tau. We already seen that in the equation in the convolution formula, that same thing we here repeated that. So we are having two type of convolution here. So what is the first type is we have to go beyond the second coordinate, that is second coordinate formula, that is limit having -2 to 0. So we are substituting x of t value is 2 into u of t, that is we are in the ramp signal we have the +2t, that is the slope value. Tut is the r of t, that is the ramp signal, which is defining the ramp, what kind of signal is ramp. So tu of t gives the ramp signal, and here h of t minus tau which gives the u of t. These are the things here. U of t, we have not have to change the value of value of impulse signal, that is h of t, which is given as the unit step signal. So we have to manipulate that, and we have that t tau has integrated that, differentiated that tau. So we will substitute the values of upper limit and lower limit. We will get the 2t. In the other hand, we have the first coordinate elements, like we saw in shaded position, that is that we have limit 0 to 1. So we will have -2t. We already seen how it's come from here. So -2t 1, that is unit signal of h of t, unit step signal, h of t which is equal to 1 d tau. We integrated that and pushing that, putting upper limit and lower limit, we'll get minus 2t. From here we have two equations, which is the DC component. We have to eliminate the values of t here, because t is the variable which is not at all need for us, so we should remove the t, so we will have the value of 2. That is the thing. Here minus t, we are getting the minus t value outside, here plus t value outside, so we will get the value of 2. That is the, from this equation, the value of DC component present in the output is 2. Thank you. Your comments are welcomed.